In this example, I've been asked to long divide the following polynomial, and then if the divisor is a factor of the original function, to find the zeros of the function. In this example, we can see that d of x would be our divisor, what we want to divide by. So we would place x plus 2 on the outside of my division symbol. P of x is the function that I want to divide. So we'd have x to the fourth. Notice we're missing an x cubed term, so we would put 0x cubed minus 2x squared. We're missing an x term, so 0x, and then minus 8. Look at the x and the x to the fourth. I would have to multiply x by x cubed in order to get x to the fourth. Multiply the x cubed by the x and the 2. So this would give me x to the fourth plus 2x cubed. Draw a line, change my signs. These two would cancel. I would have negative 2x cubed. Notice that the divisor contains two terms. So when trying to figure out how much to bring down, I just want to make sure that this piece under here has two terms. So bring down the negative 2x squared. Now look at the first term here and the first term here. What multiplied by x would give me negative 2x cubed? Well, I'd need a negative 2, and I'd need 2 more x's, so negative x squared. Multiply the negative 2x squared by the x, that'd give me negative 2x cubed. Multiply negative 2x squared by the 2, that would give me negative 4x squared. Draw a line, change the signs. These two would cancel. I would then have negative 2x squared plus 4x squared. So that would be positive 2x squared. Bring down the 0x. Look at the x here and the 2x squared. I would need a 2x. Multiply the 2x by the x. That's 2x squared. Multiply the 2x by the 2. That's 4x. Draw a line, change your signs. These two would cancel. I would have 0x minus 4x, which is negative 4x, and then finally bring down the negative 8. Look here and look here. What times x would give me negative 4x? It would have to be a negative 4. Take the negative 4, multiply by x, would be negative 4x, and the negative 4 by the 2 would be negative 8. Draw a line, change the signs. Here I'd have cancellation for both, and so the remainder would be 0. So in this situation, my divisor, x plus 2, went evenly into my function p of x. So that means that this and this are both factors of p of x. Let me go ahead and write my answer down in the correct format. So basically here, p of x in this case will equal my divisor times my quotient. My remainder was 0, so I won't have that end piece. So let me come down here and let's write that down. So p of x equals, my divisor was x plus 2, and then the quotient that I got was x cubed minus 2x squared plus 2x minus 4. Now, it asked me to find the remaining zeros. That means that I need to set p of x equal to 0, and then I need to try to factor. Well, the x plus 2 is already factored. The next piece is not factored, but we see that it fits a certain format of something I know that will factor. It has 4 terms, which means I'm going to do factor by grouping. I group the first 2 terms together. Always follow that group with a plus, and then group the second 2 terms together, making sure to keep the signs with the proper numbers. From here, just copy down your x plus 2. Out of the first group, I can factor out an x squared. That would leave me with an x minus 2 when I'm done. Out of the second group, I can factor out a 2. That would leave me with an x minus 2. Your goal in factor by grouping is to make this term match that term. If they don't match, it means that factor by grouping would not work, or I've done something incorrect. The thing that matches, you want to write down only once. So you would write that x minus 2 down once. Then, what's left over, you write in a group in its own piece. So x squared plus 2 by itself. Okay? Now technically at this time I don't need the brackets, and also I've factored everything that I can possibly factor. So now to find the zeros, I would set each piece equal to 0. So x plus 2 is 0, x minus 2 is 0, and x squared plus 2 is 0. The first one I could solve there, subtract the 2 over. I'm going to get x is equal to negative 2. The next one, add the 2. I'm going to get x equals 2. On the last one, subtract the 2. But when I subtract, I still have the x squared. So x squared is negative 2. And then go ahead and take the square root. Remember, when you do square root, you have to do a plus and a minus on the right-hand side. The root and the square cancel on the left. You get left with x. And then also remember that if you take a square root of a negative, that the result gives you a value of I that's outside the root. I can't physically take the square root of 2 without getting a decimal answer, so the 2 I'll leave alone, but I'll pull that negative outside the root as an I, and so I'll have plus and minus I roots of 2. Okay, these two guys are what I call real zeros. And then this here, I actually have two imaginary zeros, or complex zeros.